Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi, and welcome back to this amazing channel, Geeks for Geeks Practice. This is Abhinav, and today we are again with the new video of Problem of the Day. And today the problem is construct binary tree from a string with bracket representation. This is the problem of the day for 26th of November 2022, and today we are going to discuss that problem here. So just please tell me in the chat box if I am clearly audible and clearly visible to you all, and then we'll start with the problem today. Okay. Just write a one in the chat box so that I can know, and then we can start. Okay. Great, great. So let's start with the problem. So yeah, Nekaj, hello. The problem is easy, and the implementation part is a bit tough. Yeah, it's tough. It's not bit tough. It's actually tough. The problem is quite easy. Means basically we have to just transform my string to a tree. But yeah, the implementation is quite tough, and that makes this problem too a tough problem. Okay. So let's do this. Let me first share the screen, and then we'll discuss the problem. Okay. The problem is that you have to construct a binary tree from a string which consists of parentheses and integers. The whole input represents a binary tree. Okay. It contains an integer followed by zero and one or two pairs of parentheses. Okay. Now the integer represents the root value and the pair of parentheses contains a child binary tree, the same structure. Always start to construct the left child node of the parent first if it exists. So this is the basically the problem. So if you will see here, the first test case which was given to you, which is given to you is like this: 1, 2, 3. So what does it mean? It means if there is a 1 given to you, obviously the first character is given to you will be the root. After that, you will see that you will have two brackets, or you can say two basically bracket components are there: opening, closing, opening, closing. Maybe it can be one, maybe it can be two. So if the first one is nothing but the left child of this root, and this is the right child of this root. So the tree is 1, 2, and 3. Similarly, if we will take this second case, and if I will copy this particular case, so you can see one thing here. I think one bracket is what I missed. Here it should be one more closing bracket. Okay. Here you will see one thing that this is the root, And corresponding to this root, as I said you, there will be two bracket pairs. Hi Joel, hi. This one, which is the left subtree, and this is the right subtree. So this is 4. The left subtree of 4 is 2, 3, and 1. And its right subtree is like this. Now, similarly, for these two subtrees also, we have the different tree. So for 2, 3, 1, it will be like 2, 3, 1. For 6 and 5, you can see that there is only 6 and 5. Means it only has its left subtree. It don't has any right subtree. And this will be your final answer. You can see here. That is the final answer it is given. Okay. Now let's, with the help of example, the example is given to you. Let's see how we can solve this particular problem. Because we have to basically transform the given string into a tree, the most suitable method will be using a recursion. Why recursion? You will say, sir, why recursion? Why we are using recursion here? The reason behind using recursion is that you can see that for this root, we were taking its left subtree and right subtree. Then we are doing the same thing, the same operation for this left subtree. That for the left subtree also we are taking its root and then its right, left and its right subtree. Root and then its left subtree. So we are basically taking the same operation again and again. First for the root and left subtree, right subtree. Then for that left subtree, we are doing the same thing. For each and every node, we are having its left and right side if it exists. So we are basically calling the function again and again. That is why we will call it as a recursion. Okay. Now let's see how we can implement it. Because yeah, you can see that the problem seems easier. Yeah, we have 4 and we just constructed like this. But the implementation part is the most difficult thing. And this is, we can say, as something problem which is based on implementation. If I will see a topic tag, we have trees and string in it. Obviously, we have to convert a tree to string. Okay. Yeah, next we will do something similar to that. Okay. Yeah. So we will surely use stack here. Yeah, brackets are indicator here. So we will have the combination. That is why, as I told you, that this problem is something which contains a great implementation. It's not just like the implementation of tree and strings. There are also other data structures also that we will use in this particular problem. So let me tell you what the solution which I have written, what I have used here. The first thing which I have used is a map. That means a hashing is present. Now why map? Why map is used here? I've used map to basically map the index of a opening bracket to its closing bracket. So let's say for this particular string, if I will give it, this is index number 1, and this is sub bracket. So this bracket has its closing bracket here. This has its closing bracket here. This has its closing bracket here. So basically, we will use map to map the index of an opening bracket to its closing bracket. For that, we are using a map here. Okay. By the way, my new drawing room, you can see, and this is my new sofa which I brought yesterday, and I hope it's good. Okay. Yeah. अरे कौन आ गया यार? Okay. शुभम पवार ग्रीन स्क्रीन बोल. हाँ जी, ग्रीन स्क्रीन ही है यार, मतलब again the magic. That's my room only. Yeah, काफी गंदा पड़ा है आज. Yeah, back to the question. Okay. So this is what we have to do. So now the next thing that we use is the stack. So because we have we can say brackets here, as Sneha told, so means it indicates that we have to use stack here. Okay. The next thing is obviously we will be playing with the strings and the tree. Obviously, everyone knows that's a virtual background. Obviously, okay, yeah. So great, guys. So now let's implement it. So what I will do, because as I told you that the problem is quite difficult to implement, so I will solve the problem in some steps, step by step. We will go step by step, and then we will solve the problem. Okay. So the first step that we will do is the very first step that we will do is that we will map for every opening bracket. We will map the index of closing bracket corresponding to it. That's the very first thing that we will do. Very first thing that we will do. So let's see how we can do that. Okay. So what we will do, guys, is that for this particular thing, we will take the we will take the help of maps and stack. Okay. So what we will do, we will take a map. Let's say exactly. So let's say MP. So what we will do, guys? So let me index this particular string 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have a very famous problem which is called as parenthesis checker. That's a very basic problem of stack, and we are going to use a similar thing here also. So what we will do, we will have a stack, and whenever we will get a bracket, a opening bracket, we will push its index into the stack. And whenever we have a closing bracket, so we pair the index of opening bracket to the closing bracket. Maybe it seems something confusing. Let's implement it and try it. Okay. So so this is a number. Ignore it. This is the first opening bracket, which is at 1. So I've pushed 1 into this stack. Okay. Now this is a number, ignore it. Then again a second opening bracket. So again we will push its index into the stack. I'm talking about index, not the bracket. Okay. Obviously we will insert the this. ओके जोएल यार मेरी तारीफ से क्या ही होगा मेरे रूम की तारीफ से थैंक्स ओके सो ये नेक्स्ट है नाउ इट्स द सो बेसिकली जो लोग मुझे पहले से देख रहे हैं दे नो कि मेरा अभी पहले जो मेरा 2-3 महीने पहले सेटअप था वो इतना मतलब पहले मैं नॉर्मली आई थिंक अपने एलमीरा के सामने बैठ के ही लाइव लेता था बट या फ्रॉम लास्ट सम मंथ आई थिंक दिवाली में मैंने थोड़ा सा अच्छा किया अभी सेटअप आई थॉट कि हाँ लाइव वगैरह में अच्छा रहता है yeah exactly Shubham. So whenever we will have a closing bracket we will pop. Okay, so uh, but we will not just pop it. So what does it mean? So when we will have the closing bracket, so it also signifies that because we know that this is a valid parenthesis. So we know one thing. We know that the closing bracket which we have currently, which is at index number 5, this one, is the closing bracket corresponding to that opening bracket, which is at the top of the stack. Exactly this is. So what I will do, I will make the map of 3 to 5. I will make the map of 3 to 5. What does it mean? It means that for the opening bracket, which is at index number 3, its closing bracket, its corresponding closing bracket is at index number 5. Got it? Similarly, and then we will pop it from here. Similarly, as we go on, we again have an opening bracket at 6, then a closing bracket at 8. So we will be MP of 6 is equal to 8, and again pop it. Then we have a 9, so means MP of 1 is equal to 9. This is the very basic thing that we will have. Is this much part of the problem clear or not? Exactly. Okay. Now let's implement this problem step by step. Let's write the function step by step. Okay. So, okay. Yeah, 2 minutes enough. Let me take water. Okay. So yeah, first of all, let's write a function which will basically map the opening bracket to its corresponding closing bracket. Okay. So for that, I think that we will just simply have a void function and let's call it mapping. Okay, simply mapping, and we will just pass the string str. Okay, great. Yeah, we can do this with that also, but if stack is there, stack is something which can help us. So why we will not use it? It can be used. Okay, and actually the map which we will take, I will make it a global variable because we will be using that map in the other functions too. Okay, let's have a stack. Now just iterate. Okay, and I think after that we will be having if str of I is equal to opening bracket. So st dot push I. Okay, this is the index of it. Else, and don't just write else. Also write else if str is equal to closing because we have numbers also here. Okay. Yeah, we can use extra, but if you will see here, na, it has given you that yeah, you can use extra order of n. And obviously you are using a map, so if you're using a map that is taking order of n, so means you can also take this stack. Okay, either you are not taking both the things, not map, not stack. You are making the complete stack space complex order of n. That is not possible. You have to take at least order of n. So let's find take a stack also. Okay. Now we can simply write MP of whatever is at the top of the stack, means that index of the opening bracket is equal to the current index, which is of closing bracket. And after that, I will pop the stack. Okay. So this is the very basic thing which I have done. And simply I will call this function, which is called mapping, here inside this function, our original function. I will call this function. Okay. Now guys, now let's come towards the main function, the very basic function, which was like the very basic function how we are converting the tree from a string. Okay, so for that guys, now we will write a recursive function. Okay, now the recursive function is required. So now guys, for this recursive function, what we will do, first of all we will have the starting and closing index. Okay, we will have the, so this is what I have taken. What we will have, we will have a pointer called starting index and we will have a pointer called end index. Okay, and for this function we also need one more helper function, which is to determine that the current digit where we are is a digit or a bracket. That is also because there are two types of digit. Either we can have a digit or we can have a bracket. So for that also we will write a small function that is a is digit function. Let's write it. So let's write boolean is digit. And let's tag a value char ch. So means we'll simply return that if this ch is less than equal to 9 and it is greater than equal to 0. So if this is happening, that means it is a digit. Otherwise, it's not a digit. It's a bracket, obviously. So we are using here that the ch is a digit or not. That is the helper function that we have. Now what we will have, we will create a function that will be something similar to it. Okay, so that will be also this tree from string. Okay, and it will also return that node only. It will also return node only. Okay, so let's write the function. Let's write it recursion. Okay, simply. I will not make it very large. And then here we will have, first we will have the string str, and after that we will have two indexes, si and ei. So si is the starting index and ei is the ending index. And then we will call this function. Basically, we will return this function. Okay, return, or we can also simply call it, but we will return it. And after and while returning this function, str will be there. Starting index will be initially 0 and ending index will be nothing but str dot length minus 1. That is the last index. Okay. So because we have a recursive function, we obviously will have two cases. The first will be the base case and the recursive case. So the base case will be guys at the last. So in the base case, we will simply write an if si is greater than ai, because starting index cannot be greater than end index. In that case, we will simply return null. That is the base case. Okay, I will tell you why. Okay, now let's talk about the recursive case. That's very much important. Okay, so now for the recursive case. Now, guys, the very first thing that we have to observe here, the very first thing, we have a predefined function because, but I want to make digit exactly like we need to make digit. Yeah, we have a predefined function, but Himanshu, what I'm trying to make this code language independent, so that anyone who is coding in Java, Python can understand it. Okay. Hello, sir. Hello. Yes, sir. How are you? Okay, guys. So yeah. So now, guys, what we can have is let's say that it is something like this. We have 5 values here, like 245. So what will happen in that case? When we will have multiple values, let's say we have values like 235. So we will have 2, then we will have 3, then we will have 5. For this particular thing, we have to convert the string into the, or we can basically have to convert the character into the, and then we have to add it. So let's take a int num and have a while loop. What is while loop? The while loop will obviously till our si is less than str.length. This is the first thing that we will do. Okay, and the current digit should be a integer. Oh, it should be a digit basically. The current character should be a digit. If these two cases are, then we will add that digit, or you can say the integer part of that digit. So how we get the integer part? Integer part of a digit is nothing but str of I minus 0. Using this, the sky values will be subtracted and we will get the integer part. Those who don't know, please understand it from here. Okay. After that, we will have num is equal to num into 10 plus x, and then just increase the si. Obviously, so first it will take 2, then 2 into 10 plus 3, 23, then 23 into 10 plus 5, 235. This is how you will get the value. Okay, this is how you will get the value. Now, guys, so this is what we are having is the basically root value. This is the root. Okay, so what we will do, that using this root, and also guys, we will also have a si minus minus here, because at the last we have reached the digit which is not a digit. We have reached the character which is not a digit. So we have to again go back. Means we have just like 4. Then when we go to the opening bracket, which is not a character, we again go back. That we have just iterated till the digit only. Okay. Now, guys, the current number which we have, current number which we have is nothing but we can say a root. Yeah, exactly, Sneha. Yeah, the voice is going high and low. Voice is going high and low. Okay. Actually, this is also lying. The chat. I just seen the three, four chats in a once. Maybe something एक साथ ही ले जाओ. I don't know. Okay. हाँ. The thing is ना कि एक्चुअली में मुझे चैट देखना पड़ता है फोन पे, तो ये मेरे फोन पे चैट खुली हुई है, और क्योंकि अभी तो मैं स्क्रीन शेयर कर रहा हूँ तो मैं चैट नहीं कर सकता ना यहाँ पर, अदरवाइज मुझे बार बार यहाँ पे जाना पड़ेगा, मैं चैट देखूंगा. अरे 2 मिनट रुकना है. ये कौन आया था यार? अभी कोई स्ट्रीम के अंदर आया था? ये ना करो यार. ये स्ट्रीम ओपन है क्या? स्ट्रीम के अंदर कौन आया था अभी? Yeah, you will iterate for left and right. No worries. Yeah. After that, what we'll do, the current number which we have is nothing but the root. So we will have node root is equal to new node num. Okay, that is what we will have. After that, what we will have, let's say we are at SI is here. Now we know that the next character is always a opening bracket. And we also have the corresponding closing bracket to it. So this is the opening bracket and this is the closing bracket. This is the opening bracket. Nothing but SI plus 1. So first of all, we have to check. The first thing we have to check is that if this SI plus 1 should be less than equal to EI. It is checking that whether SI plus 1 exists or not. Maybe the case is that there is no opening bracket after it. So for that, we will check that if the SI plus 1 is the opening bracket or not. So if it is the opening bracket, so we know that that will be the opening bracket of a left subtree, because after root we have the left subtree. So we will find the corresponding closing bracket for it also. And then we will recursively call the same thing, the same function for this and this. So let me explain you everything, guys. Let me explain you everything, okay? How we will do. Okay. So currently we have SI and EI like this. We have SI and EI like this. So अब देखो, we have SI. We know that SI plus 1 is this is SI plus 1. We know that SI plus 1 is a opening bracket. That is what we have checked here. This is the opening bracket. And we also know that that will be the opening bracket of our left subtree. Can we find the corresponding closing bracket for this SI plus 1? Yeah, we can find using the math. So we have found, let's say this is the corresponding closing bracket. Let's call it Y. So that means that index between SI plus 2 and Y minus 1, SI plus 2 and Y minus 1 will be nothing but the left subtree. And index between, this is Y plus 2 and EI minus 1. Y plus 2 and EI minus 1 will be nothing but the right subtree. And for this right and left subtree, we will again call that function recursively. We will call that same function recursively. Okay. So that is what we are going to do here. So first of all, if it is a closing bracket, opening bracket, so find its corresponding closing bracket. And let's store it in a, let's write Y. Initially make Y is equal to minus 1 and then make Y is equal to MP of SI plus 1. Means the index of its corresponding closing bracket. Now, if Y is not equal to minus 1, means obviously its corresponding closing bracket exists. In that case, we will do root of left is equal to the recursion call and root right is equal to some recursion call. What's the root left? It will be tree between this. So means recursion str will be as it is. Si plus 2 to si y minus 1. So we will si plus 2 comma y minus 1. Similarly, here what we will do, as I told you, y plus 2 comma ei minus 1. So it will be y plus 2 comma ei minus 1. And at the last, we will return the root. And whenever a case exists that we have reached the root, so we will return null. Let's compile this. Okay, we will have si here. Yeah, this is something which we have got the right answer. Let's check for the second test case. That's quite more difficult. Let's compile it and then we will submit the solution. Yeah, let's submit it. Okay, we've got the right answer. Okay. And if we talk about the time and space complexity, so it is obviously order of n and order of n because we are just iterating the complete string and that's all. So if the string length is n, so its time complexity will order of n. And because we are having a map and a stack, so that's also order of n, space complexity. So that's the problem actually. Okay. Great, guys. That's what it is. Fine. So I hope you have got this problem. Let's meet tomorrow with the next problem. And what is the problem for today? Because the problem which is today will be taken tomorrow. Let's check it. Today we have maximum sub. Oh, sorry, okay. Add binary strings. Okay, add binary strings is an easy problem. I hope. That's also a medium level problem. Okay, we will do it. That's easy actually. No worries. Because Risit, yeah, we are checking for, because we know Risit. Okay, we are not checking for the right subtree because we know that if we have a left subtree and we know the corresponding opening the closing bracket for the right subtree, we know it that if we have the left subtree starting at si plus 1, so if we have the corresponding closing bracket at and left subtree and right subtree if it exists will be obviously from y plus 2, so we don't have to need we don't have anything to check. Yes, sure, I can share the code. Let me share the code so that you guys can check it afterwards. And maybe the case that if right doesn't exist, so that base case will be handled. What is the base case? That si will become greater than ei. So obviously it will be okay. So that's on the case. Don't worry. So this is the solution, guys. I will also update the solution here in the chat box. Okay. Yeah. So I have also updated the solution in the description so that you guys can check it. Okay. Maybe it's not done. Okay. Great then, guys. Great. And let's meet tomorrow with the next problem of the day. I hope you have got whatever we have discussed today. Okay. Okay then. Great. Thank you, guys. Bye. Have a good day. Happy coding. JFG कर लो हो जाएगा.